At Fresno State, we have a department we're trying to put together called Mechatronics, and it's a joint effort between mechanical engineers and electrical engineers, and is funded by Edwards Air Force Base. And so what they want to do is they want to develop a hiring pool at Fresno State. They want to teach engineers a little bit about aerospace, and there is no aerospace department at Fresno State. So this is kind of a joint effort to get that kind of department going. We've developed this for military, but there is likely a number of solutions for these kind of drone planes. And one of them is doing survey for farmers. We can see as your crop grows, we can see the dry spots. We can give you information in real time about what's going on from a bird's eye view. The complexity here is fairly high, and it is because of the joint effort between mechanical engineers, electrical engineers, computer engineers, and we even got a few other departments involved. There's some computer science and maybe in the future some mathematics. Basically it flies around, it loiters around an area and watches the ground for you. And we can give it a target theoretically anywhere in the world, and it could start pointing at that target. So as long as the plane's within a camera shot, it should be able to look at that known GPS location that you could go to Google Maps, look up the latitude, longitude, and enter that into our system, and our camera will start watching. We have an electric engine. It's run by two 10-cell LiPo packs, so they're the LiPo batteries similar to what's in your laptop. So they're very high density energy. So, in this whole space right here runs our entire propulsion, and this thing at 30 pounds can take off and pretty much go vertical right away. It's not a plane meant to do tricks, but it can take off with that kind of power. Underneath, stowed away under here, is the gimbal, which is the motorized, it's a camera on the motorized system. So we got one motor that can spin this way, one motor that can spin this way, and with that we can look at anywhere in the lower hemisphere of the plane. Back here is the way we communicate with the plane from the ground. So we have the ground station talks through a Wi-Fi router. Over on our trailer we have a big antenna, and they talk to each other through 2.4 gigahertz Wi-Fi router, just like you have in your house. On the, we have the ability to fly the plane manually, and that's how we'll take off, is under the control. Jason Cook is our pilot, and he'll take off, he'll manually control the plane to take off, and then we'll get up to a point we'll begin to loiter around, and we'll ask the plane to go in its own autonomous mode, and it'll start trying to fly its own path that we've already pre-designed to have it just go in an oval above the target. So in the trailer you'll see we have the camera that we use to point at the target, and the camera for a forward view, like what the pilot would see. It's all funded by Edwards Air Force and the Laos College of Engineering at Fresno State.